Okay, so hello everyone. I'll be explaining the first question of, I'll be explaining 25.1. So we see a problem where there's a guy called Vincent and he's trying to count the number of subsets of n with size at most 3. And he says that the number of subsets of size 3 is basically n choose 3. Which is correct, which gives us the number of subsets of a particular set with n elements that has size 3. And he's trying to count number of subsets of size at most 3 given a set of size n. So he says that the number of subsets of size 3 of this set which contains elements is n choose 3, and he multiplies that by 8 to get like the total number of subsets. But multiplying by 8 is incorrect because 8 is 2 to the power 3 and 2 to the power n is number of subsets of set of size n. So since each of these subsets has a size 3, he says that the number of subsets of each of these subsets of n is 8, which is correct, but this would be counting elements which are repeated. So he's going to count a single set twice. Let me show you how. So let us assume that set n, let us take set S for example. It has 5 elements, 1, 2, 3, 4, 5. So the first subset, let me assume that this is one of the subsets of size 3. This will be another of the subsets of size 3 of this particular set S, which has n equal 5 elements. So he says that each one of these subsets has 8 subsets, right? So let me list all of the subsets of this particular subset of S. That will be 5, 1, 2, 3. We'll have 8 of them because 2 to the power 3 is 8. 1, 3, and 1, 2, and 1, 2, 3. So these are the 8 subsets of this particular set. But the problem is when I list out all of the subsets of this set of 3 elements, which is a subset of S, we also see that one of those subsets will be 2, 3. Right, because the basic definition of a subset is every single element in the subset has to belong to the set 2. So since both elements 2 and 3 belong to this set, 2, 3 is a subset of this set. So we can see one thing. We can see that 2, 3 is counted twice because this will be one of the subsets of size 3 in S. This will be another one of them. So 2, 3 will be counted twice because we are going to multiply every single one of the subsets of size 3 of n with 8. So by this, since we are counting elements twice, we can also conclude that Vincent will be overcounting the number of subsets of size at most 3 of S in this case. So how do we correct Vincent's approach? We do that by since he's multiplying each one of these subsets of size 3 by 8 and he's overcounting, the way to correct his approach would be to, and since we want to count the number of subsets of size at most 3, we just count all the subsets of size 0 from n, of size 1, of size 2, and of size 3. This will be the correct answer. And this will be overcounting the number of subsets of size at most 3, given a particular set S of size n elements. So yeah, we're done with this question. I hope that is clear. So I would also like to explain another question. 25.14, since it's a proof-based question. 25.14. So the question asks us to give a combinatorial proof of the following identity. And I don't even know this identity. It's just something that I'm doing on spot. So it's a special case of something called the Vandermonde convolution identity, which I have no idea about. But what they're asking us to prove is k equals 0 to n, and choose k squared is basically 2n choose n. So the question also gives us a clue. It basically says, tells us to imagine choosing a subset of 2n elements by first splitting objects into 2 piles with n objects each and choosing some objects from each pile. So that actually makes a lot of sense. Suppose you want to choose n elements from a set of size 2n. So let us assume 2n is 10, right? And like the subset from, the set from which we are trying to choose n elements, let it be, let it be like 1, 2, 3 until 10. So let us assume we are trying to choose 5 elements from this set. So the question asks us to split S into 2 sets of size 5 in this case. So let me just choose one particular splitting. But you can split it in any way. The idea is to like have a specific split. Like you need to know which 5 elements will belong to like the first set, which 5 elements belong to the second set. So yeah. So let these be our 2 sets. So, okay, so since 2n is 10, n is 5, so we are supposed to choose 5 elements from, we're supposed to choose 10 elements from, we're supposed to choose 5 elements from set S, right? So, in the way we can choose 5 elements, okay, we can choose like 0 elements from this set and 5 elements from this set. That will give us 5 elements from S equals like 1 through 10. We can choose 1 element from this particular set, and we can choose 4 elements from this particular set. We can choose 2, we can choose 3, right? And then it goes on till we get to 5 and 0, right? So we'll be decreasing this number by 1 each time, and this number will be increasing by 1 every single time. So, I hope you understood that the way to choose 5 elements from S is to like split it into like, this is like one of the ways to figure out the number of ways we can choose 5 elements from S. So, so we just split it into 5 elements each, and we just list out the number of ways we can choose 5 elements from both of these sets. So, and the way they do that, okay, so over here, like k goes from like 0 to n. So what we can understand, let's assume like this case. In this case, we are kind of choosing like 0 elements from the first set and 5 elements from the second set. In this case, it is 1 element from the first set, 4 elements from like the other set. And in this case, it'll be 2 elements from the first set and 3 elements from the second set. And we are adding up every single one of the number of ways we get in each case to figure out how many ways there are of choosing n elements from a set of size 2n. Right, so we are adding all of these up. And also we know that n choose k is equivalent to n choose n minus k. This is just an identity and it's very simple to prove it because like we know that n choose k is n factorial divided by k factorial times n minus k factorial. And when we write this out, it'll be the exact same thing, so both of these are equivalent. Right? So 5 choose 0 times 5 choose 5 can be written as 5 choose 0 times 5 choose 0, which is just 5 choose 0 squared. And in every single one of these cases, we can do that. So that will just be equivalent to summing up the term n choose k squared, where k varies from 0 until n. So this is the LHS of the equation, and we started from the RHS, like taking a particular example. I hope this proof is clear, and I know it is not a formal proof, but this is just my intuition of the way of thinking about this problem. Thank you so much.